Black holes and you. Black holes, one of the universe's hidden mysteries, lie in the center of almost all galaxies we know, including our own Milky Way galaxy. As the name suggests, black holes are monstrous celestial objects lurking in our deep space, sucking all the matter around it, where even light cannot escape. What if I tell you we would not be here talking about black holes if it were not for them? In the ancient universe, black holes were the celestial force that stirred up the magic elements of life, like hydrogen, oxygen, and nitrogen. Unlike their name, these monstrous objects shine brighter than any other celestial object in the universe. Why? Well, just like gravity causes the planets of our solar system to orbit the sun, extreme gravitational fields will cause asteroids and interstellar gases to orbit around a black hole. This creates a superhot ring of matter called an accretion disk. So what are black holes? In a fraction of a second, a dying star releases a tremendous amount of energy, and all the mass of the star collapses into a single point in the universe, forming a black hole. The density of a black hole is so great it would be like taking the whole Earth and crushing it into a volume smaller than a peanut. Our planetary neighbor Saturn also has a similar looking phenomenon orbiting it. A simple example of this can be seen in how these beads behave when spilled onto the trash can lid. Just like the gases of the accretion disk, the beads orbit around the dense core, or lowest point of the lid, before coming to rest at the center of the black hole. The accretion disks are the key to observing these invisible stars, because they emit the light that allows us to observe them. But observing a black hole directly is not that easy. If we just simply look at one, the image is far too blurry due to high reflection from the accretion disk itself. Before we continue, I need to introduce a concept called the polarization of light. What is polarized light, you might ask? Well, natural light vibrates in multiple directions, which can cause problems with visibility known as glare. You may experience it when the sun shines on your windshield in the morning, while driving to school or the supermarket. This light can be polarized by introducing a filter that causes interference with some of the light waves, which in turn dims the light. This happens because the filter reduces the vibrations in a single direction. The easiest way to think about this is to relate it to a picket fence. This type of fence has vertical slabs of wood separated in equal segments by air. If massive light waves were traveling to one spot on the fence, then only one of the waves would be able to make it through. The other wave would hit the wood and get stuck, not being able to pass through to the other side. The light wave that successfully made it through the fence is considered polarized, and therefore less bright than it was before it passed through the fence. This is the basic principle behind the polarizing filters used by the Event Horizon Telescope, a network of telescopes around the world trying to capture the first ever images of a black hole. In 2019, after years of anticipation, they were able to capture this unforgettable image of the black hole M87. At the heart of the galaxy Virgo A, about 53 million light-years away. The resulting black hole revelations won the 2020 Nobel Prize in Physics. So, beyond black holes just being cool, why do we owe our existence to these distant celestial objects? How did black holes stir the elements in a uniform way throughout this universe for us to exist? Well, not only do they have accretion disks, they also spew huge jets of high-energy matter traveling close to the speed of light, disrupting space millions of light-years away. Scientists believe that this disruption was necessary for the uniform distribution of elements from far supernovas to us here on Earth.